So after solving lengthy equations, strategies, you are going to arrive to solving force, like reaction, moments, like that. No? Another way of solving statically indeterminate structure is by displacement method. No? So if there is force method, there is also called displacement method, and that is opposite of the force method. Okay, it's just a reciprocal actually, because the equation is very simple. No, force is equal to constant times deflection. No, so if you still remember physics, that force is equals to spring constant times the displacement. Okay, if you know the displacement, the spring constant, which can be determined in the laboratory, you know, or maybe if you have a spring and then try pushing it like that until it deforms, no. So if you can graph the force deformation, so you can have a graph, a good graph, no, a linear graph, and the slope of that can be what we call as a spring constant. So it's easy actually. And that's how some kanang mga classical nga timbangan class, kanang mga spring pa. Yan ang gamit, no? Ang ilalagay determinate ang spring constant. Okay? And then ilan na nadaan gi-calibrate so that pagbutang nimo sa mga isda o bugas, mo deflect ang spring, mo tuyot tong iyang scale. It depends on how, no? Naman sa dili mo tuyot itong timbangan nga mga espada nga pag bira nimo, imo lang i-balance, no? So, they have already calibrated that, no? Calibrated that. Sa electronics, mao gyapon, no? Sa electronics, gibuhat gyapon sila og kanang gitawag nato sensor. Sensor, we call that strain gauges, no? Strain gauges. Mo na siyang gapadagan sa mga timbangan ng electronic, no? Ang strain gauges, gamay kay nga changes na siya, doon na siya equivalent na mga voltage. Ang voltage i-convert nila into force, ingana, no? Kanang mga dagko nga mga scale nga timbangan sa mga nga track na timbangon, no? So doon na siya gitawag nga load scale. Kanang load scale is a bigger version of the strain gauges, no? Electronics na nga paagi, dili na spring, no? Okay, so that's how they measure force now. Because of this electronic age, digital age, so they can measure it digitally. No? But doon na po na siya ay synonymous na po na siya sa ito na to classical na pamaagi na spring. No? So structure is still spring, no? Wala pa dili pa digital ang atong balay, no? Dili pa digital, no? And digital is something like another world. No? So we are living in a real situation. We can touch the beam. We can still touch the column. And they are still made up of material in which they are made up of a certain material and it has sizes. And you know, the size of material and the kind of material constitute what we call stiffness. It's the product of E and I. No? I meaning moment of inertia. So when you compute for the moment of inertia, you use the dimension. So inertia is just like area, no? In fact, the other word of inertia is the secant moment of area, no? So inertia refer to the size, okay? Gidakpon, yeah. The stiffness does not only comes from its size, it also comes from the kind of material. So dili lang siya sa gidakon pod, kundi sa klase, no? Sa klase. So kung maayo siya nga klase unya, dako siya iyang dimension, so gigon siya, no? So mo na siya bot pasabot. So it's a product always of TI, no? So it has a spring constant. So force is simply equal to spring constant times deformation. Okay? So mao na siya, gitlaan. Now, kung mingon ka opposite sa stiffness is flexibility, so you can also make an equation, no? Like displacement is equal to force over spring constant. Ano lang, no? So, simple kayo ang analogy na niya. So, pwede ka mo gamit og displacement method, pwede sa ka mo gamit og force method by using force is equal to spring constant times displacement. If you do not want force method, then ato ka sa displacement method. Unsa man ang displacement method? Ato yung po yung equation ni mo kuhaan, no? So, may kung ang force equals to spring constant times displacement, then kung mo ni mo equation sa displacement, ang equation may una ni. Displacement is equal to force over the spring constant. So, like that. So, but they are just a name, no? Force and displacement, no? So, you cannot simply relate the simple equation into the methodology that I am going to discuss now, which is still force method. So, ang topic is just a continuation of what we discussed the other meeting, no? Although the other meeting we just discussed an indeterminate structure which has one degree indeterminacy, no? So last meeting I also teach you how to determine the indeterminacy of the structure, no? So this morning we will continue with that. Okay, so we will springboard from our last discussion. Okay, so I have here. So this is our topic for this morning, no? So I just capture this from the last notes. So basically it appears from the last notes, no? So the definition of indeterminate beams, okay, and how can you determine of indeterminacy? So you see to determine the number of degree of indeterminacy is just determine the number of unknowns and then minus it by 3 because why 3? Because there are only 3 equations available in equilibrium, no? For plane analysis lang, for 2D analysis. Ever since we are dealing with 2D, no, we did not use 3D. So 2D, that means that the 3 equations available are the summation of forces x and summation of forces y, and the other equation is the summation of moment everywhere. Okay, so you have 3 available equations. Now, in my example, we have a beam with one extra support in the middle. So this happens to have 4 unknowns, no? Because at this one of the support here must be a pin so that it cannot be dragged horizontally. No, there is still a support, horizontal support. Okay, so at least one will be a pin and the other 2 could be a roller. If the other one, if one is pin, so meaning it can support horizontal reaction and vertical reaction, so that's 2. And then for the 2 other support, if there are rulers, so only one vertical reaction and vertical reaction, that makes 4 unknown. You deduct 4 by 3, so you have 1. Okay. Now our case this morning is what about if I will make this two supports. Okay. So well, I can make these 2 supports. So if I can make that into 2 support, I will ungroup it. Okay, and then maybe I will copy that. Copy paste. So I have now 3 supports. Okay. So dito see that's still a roller. Okay, that's still a roller. Okay. So you have 3 rollers. So rollers can support vertical reaction. So I still copy that. So that's now the case, no? So you have a beam which has 4 supports. One of them is pin, and the 3 could be a roller. So that makes 5 unknowns. 4 of which are vertical reaction and 1 is horizontal reaction. Okay. So if you have 5 unknowns and you have only 2 equations that can be established using equilibrium, that means you have an indeterminacy of 2 ni siya secant. indeterminate to the second degree. Second degree. So, second degree na siya. Second degree. Okay. Why? Because there are five unknowns, four vertical reactions, plus one horizontal reaction, as can be seen here. So you have what we call 5 minus 3 is equals 2. So this is a second indeterminate structure, indeterminate to the second degree. No? Indeterminate to the second degree. Meaning the degree of indeterminacy is 2. Okay. Let us have more about indeterminacy. Like for example, I have a beam which has another support, no? Let us say this will become a fix. The other one is fix, no? Fix, yeah, fix. Okay, fix, yeah. Ako ni wala ko yung pag-go. Dili ni siya ruler, dili ni siya one. Let's say that's still a ruler, okay? But on the end, let us see, na siya ay fix, yeah, fix. Okay. That's a fix. Okay. So you have pin, roller, and then you have still fix. So you know what fix can do? It can support a vertical reaction. It can support a horizontal reaction. And it can support also moment. Okay, we'll make moment. But I do not know how to make a curve, no? So I'll just try to make a curve. Okay, that one. Okay, then I'll put line. So okay, wait a moment. So if we are going to account how much force is there, you have 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 3, that's 8. So you will have 8. Therefore, this is fifth degree. And if you have fifth degree, you will have 5 equations also. 5 equations to solve. So if you are going to transform equation into a matrix equation, that means that you will have a 5 by 5 square matrix. No? You have 5 unknowns, and you will have also 5 equations available. But if you intend to solve not by matrix, you can solve it in classical manner. So you do some what we call that elimination method, no? By elimination. Okay. So that means okay, there will be 1, 2, 3, 4, 5 vertical reactions, 2 horizontal reaction, 2 horizontal reaction, 2 horizontal reaction, and a moment. So that makes 5 in a moment. Okay. So that means that as the degree of indeterminacy becomes bigger, like you have 3, 4, 5, the solution also becomes harder. Not really harder, but longer. Okay, longer. So last meeting we used to solve 1 because the degree of indeterminacy is only 1. Okay, just like this problem. No, this. Okay, so this time we will have 2 supports in the middle. Okay, and we still have continuous beam 12 meters long, supported with four supports. One of them is a pin, and the 3 are rollers, are in equal distances. No, so if we are going to, the purpose here is we are going to determine the shear and moment, meaning you have to analyze the loaded beam. Okay. Now, if you are going to ask what are the reaction of here, what are the reaction of the support, You cannot say that the vertical support is just equal to 20 times 12 divided by 4, no? The total load is 20 times 12. That means the total load is 240. And there are 4 supports. That means that each of them is 40. Uh, the real answer might be close to that, but it's not really equal to 40. No? It's not really equal to 40. Just like in our previous example, when there are 3 supports, it does not say that nga kuan nga equal sila. In fact, nakita nato nga ang sa needle double siya, double yang load, no? Double yang load. Okay? So mao na siya, no? So there is a difference kung naa ka sa tunga sa lingkuranan o naa ba ka sa daplin naglingkod, no? Naay difference, no? Kung naa ka sa daplin medyo naay tao nga kung ang lingkuranan tulo ra ka buok space ang available, ganahan sila magpadaplin, no? Eh ano man, doon sa bintana, makakita sila sa unsa, nasa uban nga dili ganahan, kung patunga sila. No? Okay? So, yun na. So, there is a difference. So, kung nasad ka sa tunga, kung ikaw sa nag-alsa, ni kahoy ni alsa tulog mo, mabukatan yun ang nasa tunga, no? Ang sa tulog, yun yahay lang. If you are going to analyze it using the unitary area. No? But here, we are going to analyze this one using compatibility, no? By force method. Okay? So again, we are going to determine the degree of indeterminacy. So you have 1, 2, 3, 4 vertical support plus 1 horizontal reaction. That means you have 5 unknowns. Then you have equations available 3. That means that you lack 2, no? So other equation is from compatibility. So other equations. So we made 2 equations using compatibility. Okay. So you have 3 from equilibrium and 2 from compatibility. So you can solve, no? Because you can still establish equation from compatibility. Now degree of indeterminacy is 2. Okay. Now the method of solution is method of consistent deformation or force method. Okay. How are we going to solve this kind of problem? Okay. So sao na to siya pag-solve ng problem. Okay. You know what happened to the beam? Ang exact niya nga depicted structure. I will do the depicted structure because this will be our basis. No? The depicted structure will look like this. Okay. That's how the depicted structure looks like. Okay. Ito ni sa color. Sa format. Ito ang line niya. O yun ani. Color sa. There it goes. So that's the depicted structure. Okay. So okay, that's the real depicted structure. How are we going to analyze this? Okay. We will analyze it using method of consistent deformation. Ang method of consistent deformation is yun ani ang pamaagi niya. Himuon niya ning first himuon niya ning kuan. Simple beam, no? So, himuon mo siyang simple beam. So, para mahimo siyang simple beam, i-remove nimo ang duha ka support. No? Removing of the supports will be up to the one that analyze. Kung unsay mas convenient sa iya, no? I-remove niya ang duha ka kabok sa tumoy o i-remove niya ang duha sa tunga. So, in my point of view, it's shorter to remove the 2 middle support so that your simple beam is still magamit kang formula sa simple beam nga nasa table. Then simple beam is easy, no? A beam like this, no? Okay. Pwede man ni kuhaon ng duha. It will also arrive into the same answer. So what happened is that if you are going to remove the supports at 2 add 3, so this now is 1 will become 1. Ako din po na. Wala siyang gamayan. Muna na ako na siyang 12. Okay, mo ng 1. So, nakakay 2 din mo. Nakakay 3 din mo. So, wala siya mga points. No, no points. Okay. So, 4 na siya. Okay. So, may tabudan na siya. Muna siyang gitawag o doon na siya reflection diha. Ang tawag na niya, of course, kung ang point man, ang point, ang point 2 man, so we call that delta 2. Okay? Yeah. So, may tawag itong sa delta, sa 3, sa 3. Wait lang. Siya tawag na. Ang tawag anin niya reflection din sa 3, halim gikuha ang support at ang tawag niya is delta 3. So, ato na lang yung kopyahon. Ati, move ka dito. Okay. Ang tawag niya is 3. Okay. That's delta 3. Okay. So, but we know nga, di gini siya mauwang tinuod gabi. Pero tinuod gabi mo, lagi ni. We will just use this as a means, no, na makuha na to depiction niya, no. So, if we remove the two supports here, because that's how method consistent deformation look likes. So, if you remove that, the beam will go down like this. So there will be deflection at point 2, where you remove the support at point 2 and at 3. Okay. So that's it, no? Now, determining delta 2 and delta 3 is not a problem. Okay? Why? Not really a problem, no? We discussed already determining deflections, no? That's one of the problems that we have earlier. How to determine deflection if you have a simple beam? There are many ways how to do that. Number one, you use the table. Now, if you are going to use the table, you should see to it that kung sa forma sa imong structure, parehagin sa table. No? Now, kini siya, dili ni siya lisod pangitaon, no? Ikaduha na method, you can apply katong gitawag og constant integration method wherein you have a differential equation of second order of y, and then what you'll do is just integrate it. Integrate twice, you will have a constant 1 and constant 2, which can be determined because there are also known boundaries. No? There are boundaries which have known values. Okay. But for me, I'm just going to use what we call that table. No? Table. Okay. So that's what I do. Remove two redundant supports. Okay. Now what support you are going to make, it's up to you. No. In my case, I remove the middle because I found it easier. And yeah. In fact, here's delta 2 and delta 3 are equal from if you are going to reason by symmetry, there's the curve is symmetrical. So if you can determine delta 2, because they are of equal distance from the left and the right support, uh, from the reason of what we call this symmetry, delta 2 and delta 3 are equal. Okay, they are equal. And there's no need to determine delta 3 if you know delta 2. Okay. So delta 2, so we have to solve the equation delta 2, copy, comma, delta 3, comma, and delta 2. Okay. So that's why no, we have already removed the redundant support. We know that we will need two equations, two more equations from compatibility, and we have not yet established one. Okay. So, okay, next is you are going to apply a unit load at the points where the reaction are removed. There are two reactions that are being removed from this time. So you are going to apply a unit load on those 2 points one by one, not simultaneously, but one by one. Okay. So this is what happened. Okay, so I will rewrite this because these are still based on the previous problem. I will make the font smaller. So this will be 1.1, and then this is point 2 somewhere here, point 2 somewhere here, and this is my point 4. Okay, that's my point 4. Okay, so I will apply a unit load at 1. Okay, at 1. There is, will apply unit load 1. So what happens is that because you apply it on this one, the curve is not like this symmetrical. In fact, the curve will be a lot like this. The curve will like go like this. Okay, that is point 1. Okay, mauna siya ang pinatilisan ng line. Dahil sa may color. Okay. So, wag yung una na, dili siya symmetrical. Why? Because the load is biased to the left. Okay. I will call this unit load 1. Okay, 1.0. So what happened is that there is this deflection. Okay. That deflection is equal to if we are going to use the two subscript system, you have the per subscript and two subscript. So the per subscript is where the load is being applied. Okay, where the load is being applied and where the deflection is being observed. So you apply load at 2 and you observe the deflection at point 2. So that's simply you have a subscript here of load at 2. But what happened at point 3? Well, naya ko na siya deflection. Hindi na siya mag-zero. Na siya. Naibahin. Okay, pero yung bahin, hindi pa sa delta 2. So, kung dito sila pareha, lain na yung halan. So, ang halan kao niya, na niya, ato din kopyahon, para din na magkuhan. Okay, ato na siya butang dito, i-paste din na pa na siya. Mao na siya ang delta 2, either this one will be where the load is being applied. Sayo. Where the load is being applied, so that could be 1, 2. So, di sila pareha, no? This is 2, 2, and observe at 3. So like that. So that's it. Delta 2 to and delta 2 3. Now, ayaw ka pala kanig mabalini siya, no? Hindi siya 3 to. Kay according to law of reciprocal theorem, pwede na siya mabali-bali. Equal na siya. Delta 2 3 and delta 3 2 are equal. Okay. So, doon na yung mga proof anak niya. So, you don't have to be worried whether this is 3 2 or 2 3. No? Basta you are consistent only. Okay? So, that's how it is, no? Now, I have mentioned earlier nga, there are two supports you remove. And that you are going to apply unit load one by one. So, kaysa pa ka nag-apply yung unit load. So, you need another one here in the bottom. So, what I'll do is copy this. Copy, paste. Okay, and then I will copy. I will copy also this one. 9 points. Yes. Okay, no. Yeah. Okay. So here you are going to apply a unit load. This time is at 23. Okay, 23. Hindi saan ka na kung pag-apply na. Pwede mo siya na kunin mo. Kopyahan ko niya siya. Copy that. Okay. Paste. Yes. Paste ko na siya. Ako na siyang i-flip. Boom. Ako na siyang i-flip. Flip. Horizontally. That's it. Okay, so kung apply na ko din niya, ang code niya, dili siya kung symmetrical, kung dili bias siya to the right. Okay? Ano man, ang load, ang man dito, ang load, ibutang load. Ang ibutang niya. So what happened then is that there will be deformation at points of interest. So din na siya deformation din sa tree, din sa pikas, naagyapon siya. Kung sa may ngalan laan of course, hindi mo sila pahayag value, hindi sila pahayag ngalan. So, ang ngalan nila, maduduol lagi po namin niya. Okay. Ano ito din Kini siya gitawag o delta 33, no? Ano man. Okay, the first subscript is where the unit load is being applied. Mag-apply sa point 3. The second subscript is where the deflection is being observed, point 3 hapon. Kini siya is, may mo siya 3, 2. 3, 2. So, anong 3, 2 na? Okay. The first subscript refers to where the unit load is being applied. Wa man gi-apply sa 2 ang load, naman sa 1. So 3 gid siya ya. Anong 2 man ang second subscript? Because you observe the deflection at point. So that's why it is. Okay. So complete na. Humana nimo duha ka unit load apply. I-apply nimo sa mga point nga asa nimo gi-remove ang deflection. Okay? So basically, if you are going to add all of this deflection, it will become like this. It will become like this. If you are going to add this three, like for example, this one, from there, ako na siya from there, ako na siya i-add. No? That one, and that one, it will go back to, must go back to 0. So the first equation then is, okay, if I am going to multiply this by R2, see, like for example, if I'm going to double this, or the deflection also will double, no? So, like for example, I will make my unit load 10 times. The deflection also will be 10 times. So, any number I apply to the unit load will also be the number of the number of times that your deflection will increase. Okay. Now, I'll say that I will multiply it by R2. R2. Okay, R2. Hindi siya R2 dito. R2 lang. So, the deflection also will be multiplied by R2. Okay? May mo siya multiplied by 2. By 2. Now, dili lang ka na. Pati igap na siya. R2. Okay. R2. So, kung multiply ko na siya x, ulihan ako ng R2 og x, ulihan ako ng x. Okay, but since my choice is different, di ko gagamit ng XYZ, but rather I use R2, so I just use this one with R2. How about this one? If I will multiply this by M, the deflection also will be M times. Even the shear in the moment will be M times than the one previous. So if I multiply this by R3, so the deflection will increase by R3 times. So that will be R3, there will be R3 here. Okay. So Now, I mentioned that if I am going to add all this restriction, it will go back to this. It will become 0. So, I will have it here. R2 times delta 2, 2. Doon pa rin siya add in. Another equation. Paste. Then we have plus. We have R3. R3. And 3. Okay. So, R2 delta 2, 2 plus R3 delta 3, 3, 2 plus delta 2 is equal to 0. Okay. Now, how about the second equation? Because I have mentioned a while ago that you need two equations. Isa pa na siya ka equation yung may mo. Ang isa, no? Kopyaano ni mo na. Paste. So, kini na sa di mo o equation. Okay. So, ang itabuda na is may mo siya naman Okay. Paste. So, R2 delta 2, 3. Then you have R3 delta 3, 3 is equal to. Okay. So these are the two equations actually na yung ma-determine. Now, you can convert this into matrix if you know how to manipulate the matrix. I'm sure you know because the matrix form, the matrix form, ang napalaban sa equation. Insert equation. Okay, matrix. Okay. Now, sundan ako na siya. What's it? Equation. Okay. Then, yun siya. Okay. What will be inside? That will be sigma. Subscript of 22. This one is still sigma. Then you have subscript of 32. Then have sigma. Subscript of 23. So sigma. Subscript of 33. Then you have Victor. Here, Victor. Okay, can you use that? What is in the Victor? You'll have R. 2. You'll have R. You'll have 3. This equation equal to Still a Victor. You'll have delta here. Delta 2. Delta 3. So that's how it is. That's the equation. Okay, that's the equation we are looking in matrix form. Okay. Basically, here, because of symmetry, delta 2 and delta 3 are equal. Okay. And one thing that is equal is delta 3, 2, and 2, 3. No? Basta kay, pagyan na sa number, balag mabali-bali na siya. Like for example, 3, 2 siya, 2, 3 na siya. Isa yung mukha na na. Kung binagyan siya, equal sila. We call the law that proves that as Beatty's law, no? Law of reciprocal, no? Law of reciprocal. I forgot the next word, no? So this is the equation. How you are going to obtain? How did you obtain this first equation? I-add lang mo na siya, no? Okay, it will surely go back to 0. Okay. So that's why it's 0. Okay. This one will be negative then. Negative. Negative na siya. Negative na siya actually. Negative kaya bubalin na may una negative. Okay? So how about the second equation? I-add lang ako na siya so that it will go back to 0 because right now this one is not 0 and this is not real. This one is the real. Okay? And we are solving for this load and this load to make that 0. So your unknown is R2, R3. So if you wish to determine the equation, you just know how to inverse this one. So solution. Ang sarap ito akong kuhan. Namahalang ito akong kuhan. Equation. Insert. Pagawa na ito guys. Okay, ang solution na niya is equal to you have a vector here. R 2 R 3 is equal to the inverse. The inverse of 2 by 2 here. Delta 2 delta 2 delta 2 delta multiplied by a vector of negative I see negative. That's negative delta. So I forgot to put negative in here. Differential na siya inverse. Okay. So money ang solution. Money ang solution. So all of these are constant. You can solve that. Okay. So we will start to solve the depiction of delta 2 3. So I will solve here solve solving for delta 2 delta 2 and delta 3. But I have mentioned a while ago, due to symmetry, delta 2 and delta 3 are equal. So delta 2 delta 2 is equal to delta 3. No? Due to symmetry, now we will have a case number using table of the flexion here. So I have my equation equal to ang depiction niya na equation is y equals to wx. Okay. Ini siya, y equals to wx. Ano siya na siya? y equals to wx over 24 ei. Y is equals to wx over 24 ei multiplied by quantity L cubed minus 2Lx squared plus x cubed. Okay, mao na siya, no? Ang formula. So, ako na isulat din. Nagamay ni. Okay. So, mao na siya yung equation din. Y is equal to ako na yung ilukumon sa kuwan. Wx over 24 ei times quantity L cubed minus 2Lx squared plus x cubed. Ako sa kayo mo kung na capital L na naman. Superscript. Ini capital L niya ito siya. Superscript. Superscript. Okay. So, W is equal to minus 20. L is equal to 12. And X is equal to 4. Okay, so, Y is equal to now ko itong second parenthesis. Okay. You have 12 times 12 times 12 plus x, which is 4, minus 2 times 12 times 16. So na kay 1408. 1408. The unit of the inside is meter to the cube. Okay, you have 12 times 12 times 12 minus 2 times 12 times 12 times 16 plus 4 times 4 times 4. Ah, 1.5 to 1. Ito, 1.5 no? 12xy cubed plus 4xy cubed minus 2 times 12 times 12 times 16. Huh? 1408 lang yun. 1408. Ano ito ba niya? Okay. How about the inside? So you have minus wx, so 20 times 4, you have 80. 80 divided by 24. So 80. 80. Okay. I don't want to be 24. 20 divided by 6. 20 divided by 6 pi. Ano siya ang ano siya ang yung depiction. So 20 times 1408. 20 times 1408. 12816 divided by 6. So 20 times 1408. 28160. So this is 28160. Okay, 28160 divided by 6 ei. Okay, that's the y. That's the y at 2. Y at 2. Or simply delta 2. Okay, so this one will be okay. That's it. So that means that delta 3 is also the same. Okay. Due to this load, wala siyang value sa delta 2. Okay. Now, on this one, wala na ni. Okay. Now, kining delta 2 is equal also to delta 3 at the same time, no? Imo naman siya flip horizontally. We are lucky here that they are equal. So, we need only to solve delta 2 and delta 2 Okay, delta 2 So, we use case number case 2. No? So, case 2, case 2, case 2. Ini siya basically case 1 siya, case 3. Okay, case 3 ba? 1, 2, 3, case 3. So, we are going to solving for this one, delta 2 and delta 3. Okay, there is this. So, it's not to solve. Now, if I'm going to look on the equation, I have this equation. So, I will use A is for delta 2, I can use A equals to X. Yeah, I can use the second equation. For the first one, I can use the first equation. The second one is I use the equation. So I will use the second equation here. Y is equal to PBX over 6 LEI. PBX over 6 LEI. So that's the first. And the second one, let's put it here, is L squared minus X squared minus B squared. L squared minus X squared minus B squared. Okay, all of these are superscript. Okay, so here we have A equals to 4, L equals to 12, and B is equal to B. B is equal to 8. X is equal to 8 or equal to 8. So we can use this now. B is 8. Okay. So we are solving for y 2 equal to 2 is a subscript, and this one is a symbol small b. Okay. So first I am going to determine the first parenthesis. The first parenthesis is b 8 times x. So 8 times 4 is 32. over 6L, 6 times 12, that's 72. 72 PI. So PBX, yeah, no, yeah, PBX. So B is 8 times 4, or 32 divided by 72. 32 divided by 72. So you have, okay, multiplied by L squared, that's 144. 144 minus 4 squared is 16, minus 64. You have 64 here. 64. So what we have is delta 22 equal to 32 times 64 divided by 72. So 32 times 64. 2048 over 72 EI. Okay. So we are also lucky because by symmetry, delta 33 is also equal to that. But this is not always the case. So that's it. Okay, so you have delta 2 to delta 3 equal. Now we need to solve delta 32. No? Delta 32. So delta 32 is when A is larger than X. So when A is larger than X, A is larger than X. We can still use the same equation. Actually. So here, we can still use the same equation. But here, this will become sigma total. Okay, 32. 32. Okay. So if this one, your A is 8, and B is 4. Okay, so you can apply this equation as if this 8, and this one will become 4. So this one is still the same. That's 6 times 12. 6 times 12. 6 times 12. PBX is that be B 4 times 4. X is equal to 4. So this one will become 16. 16. Okay. So that's it. Equal to 16 times 64. 10 to 4 over 72. So more na siya yung tabas. Kulang lang na yun. So minum siyang 10 to 4. verse 72. Okay. Now, also, that's the equation. Okay. So here, all the four are already known, no? So we can solve them by matrix, no? So by matrix, EI will basically cancel because all this term here are having EI. And if you invert that, EI will be on the numerator, and here is the denominator. So EI will basically cancel. Okay. Even from this equation, if this is in terms of EI, this is in terms of EI, this is in terms of EI, you can already eliminate them. So it will not disturb your equation in your matrix. So your matrix equation will become this. So may matrix equation ni mo may unani. Okay. So doon na kay 2048, 1 over 72. And then this one is 1024, 1024, 2048 is equal to 1 over 6 to 8160 to 8160. So you have R2 over R3. Yeah. So actually class I have solved this, no? R2 and R3 are equal. Okay, so we have a solution. solution. I just skip no the the R two R three equal to uh, this 110 110 so this is the solution. Okay. Okay. So on a chance solution because the equation still have time to write this. You have an equation like this. Okay. So this will become 2048. 48 divided by, actually this is 72. And here you have 10 to 4 divided by 72. You have 10 to 4 divided by 72. 2048 divided by 72. Multiplied by R2. Is equal to, we have a positive here, so the positives. We have 28,160 divided by 6. This one is also the same, 28,160 divided by 6. Okay. So you have this equation that will appear here. Okay, so that's the equation. Okay. AI is already cancelled. Now solving that, no, I know your calculator can solve that is equal to this. Okay. Only that we do not have time, but you have already solved R2 and R3 here. So the rest, if you apply what we call a principle of equilibrium, you can solve R1 and R4. In fact, R1 and R4 here, I will say that by equilibrium, the equilibrium, okay, R1 is equal to R4. R4 is equal to 10 PM. PM. So that's it. R1 equals to R4. Okay. So we will have this as our shear diagram. This will become 10. And then this very short one. Then here you have bigger. And that one will become 110. 110. Then the second one, 10, 4. No, this is 30. 10, 20 times 4, 80. This is 70. And then here, you have 40. Okay. And then here you have also 40. Okay, so ako siya ito. Then have 40. Ayun ba siya? Then this one, have 40. Have 40 again. Then saka na siya. Saka na siya. Hindi na siya. Hindi ka 70. Okay naman. This will be your shear diagram. Okay. So, yung ana yung shear diagram. Yeah. And you have basically 1, 2, 3, 4, 5 zero shear. So you'll have shear moment diagram that looks like this. Last time yun. Shear diagram that looks like this. Finishing ISO. That. That. So here you have a shear diagram that looks like this. For this one, you have and here you have a shear diagram that looks like this. A moment diagram. You have maximum moment somewhere here. Okay. The secant is you have moment diagram that looks like this. Maximum here, maximum somewhere here. Okay, that's it. No Batman, no? No Batman shape. So, and basically you can determine the moment by using the area of the shear diagram. Okay. So you can determine that one. So we run out of time, no? But I able to analyze this. So I just have some issue about using this computer, not by computation, but it's really very difficult for me to use my computer as a blackboard. No? If I will be doing this with blackboard and chalk, I'll be much faster since I'm used to that now. Using my finger and the mouse is different situation. Okay, so we do not have time anymore. Maybe we can continue this later. No, I will recap this later. So that's basically the discussion I have to uh, trying to discuss to you this morning class. So we'll discuss this again later. So thank you for coming. So I will save this. So if you're still here, so I'm able to finish it, but I will just repeat it this afternoon. Okay. So if you have some questions, please reserve it later. No, we do not have time anymore. I still have another 2 hours. So thank you for coming.